How important is your data? Every day, billions of data are created and transmitted by human beings from one party to another through the internet. We send and receive messages, documents, images, and even personal information easily with the aid of modern technology and the internet. Statistics have shown that there are about 2.5 trillion bytes of data created each day, and over the last 2 years alone, 90% of the data in the world is generated due to the rapid growth of Internet of Things. This proves that data is the power in this modern computing world that drives the success of businesses. Customers' trends can be predicted, and sales can be increased by utilizing data. However, with the current advancement of technology that is improving day by day, the greatest fear ever experienced by human beings is the flaw in data security that might cause information or privacy leakage. As technology advances, hackers are discovering more ways to overcome existing protection measures, which is indeed a threat to us. Imagine that your personal data like your addresses, bank information, and social security numbers got leaked through the internet. This can pose a great damage and a massive loss to you, as unknown persons may misuse your personal information. Thus, data security has become the topmost priority to human beings today during their transactions through the web. Protection of data and cybersecurity measures should be accelerated and improved at a pace that is faster than hackers cracking our protection shields to keep our data safe. So, how to protect your data when you are transacting on the internet? The easiest way is to hide it from other people. Then, it will not attract hackers and criminals that are eyeing on your personal information for illegal purposes. Steganography, or better known as hiding data in images, is the solution for this issue. It is the art of hiding information in plain sight to avoid detection. What is plain sight? This means that it is unnoticeable. By just looking at something, you will not notice that there is a hidden message inside. It is almost similar to the concept of camouflage, like how soldiers would paint themselves in the same color as tree leaves to avoid detection by their enemies. In my research, secret data will be hidden within another image such that the presence or contents of the hidden data cannot be noticed by someone unintended. In other words, the secret data will be camouflaged inside an image, and by just looking at the image, you will not notice that there is hidden data inside. The processed image will look exactly the same as its original. This is what my project is about. I will be researching on hiding data in images using deep neural network. What is a deep neural network? It is an artificial neural network with multiple layers between the input and output layers. The word deep signifies the multiple layers in the network. Like how human brains are made up of connected networks of neurons, the deep neural network will simulate these networks and get computers to act like interconnected brain cells, learn, and make decisions like human beings. Among the various types of networks, the convolutional neural network is chosen as the method to be used in this research due to its excellent performance in image classification and identification. In this network architecture, there are three main parts of the framework. The first part is the preparation network that takes in the secret image. If the image appears to be smaller than the cover image, then this network will be responsible to increase and match the size so that both of them have the same size for better encoding purpose. Next is the hiding network that takes the output of preparation network and a cover image as input. It will hide the secret image in the cover image and produces a container image that looks identical to the original cover image. Lastly, the reveal network is used to decode the secret image. It receives the container image from the hiding network and removes the cover image to reveal the secret image. From this model, the loss can be calculated from two error terms, which are the reconstruction loss of the cover image and also the reconstruction loss of the secret image. In this research, the convolutional neural network model will be trained with different parameters to produce an optimized model
which can achieve the best results with the highest accuracy and minimal loss. Thus, various experiments are carried out, such as the performance analysis with varying activation functions, learning rates, and the number of epochs, as well as the observations of the program execution time. This shows an example output of the program after hiding images. The first column shows the cover image inputted, followed by the secret image inputted. Then, the next column shows the output image that has a secret image hidden inside it, followed by the decoded secret image. Lastly, the two columns are the difference between the inputted and outputted images for both the cover and secret images respectively. The expected result in this research is that both the encoded cover image and decoded secret image should be the same as the original images inputted. This is to ensure that the secret data will not be detected by plain sight, as well as to retrieve accurate information after the process of steganography. Thus, the ideal result would be a pitch black output in the difference image columns. Let's observe the output results from experiment 1. For this experiment, the performance of the model is analyzed when it is trained with different activation functions. Here, comparison is made between the rectified linear unit activation function and the hyperbolic tangent activation function. Other parameters such as the learning rate and number of epochs are kept constant. As shown from this output result, it can be seen that the model with the rectified linear unit activation function had performed better. This is because the model with the hyperbolic tangent activation function failed to maintain the original colors of the input cover. It can be seen that there are some differences between the input and output cover image as well as secret image, where some of their features are visible in the last two columns. Thus, this shows that this model did not successfully hide the secret image inside the cover image. The difference in cover image might attract hackers, and the decoded secret image lacks information. On the other hand, these problems did not seem to occur to the model with the rectified linear unit activation function, which means that this model had performed better in hiding an image inside another image. This experiment is repeated for experiment 2 and 3 by varying other parameters like the learning rate for experiment 2 and number of epochs for experiment 3. For all these experiments, their execution time are observed and compared to analyze their performance and determine the optimized model. As a result, the optimized model with the highest accuracy is identified, which is the model trained with the rectified linear unit activation function, a learning rate of 0.0005, and 600 epochs. This graph illustrates and compares the mean loss of the models that are trained with different parameters. As observed, the optimized model has the least amount of loss compared to other models. This means that it can hide an image inside another image successfully with high accuracy. As shown in this output result of the optimized model, it can be seen that there is minimal information loss in the secret image decoded, as there is no difference between the input and output secret image. The cover image is also perfectly encoded, and this can prevent the exposure of secret data to third parties. Hence, this concludes the outcomes of my research, as data has been successfully hidden inside an image using deep neural network. Given its ability to protect secret information from third parties, steganography can be a useful application that can be implemented for data security and protection. By doing so, our data can be protected securely during transmissions on the internet. Anyone who comes across your carrier image will not know that there are secret data hidden inside, and therefore, the data will be kept safe with only you and the receiver being aware of it. Apart from its uses for data security, Future research can also be done to apply steganography in digital copywriting. A copyrighted image can be hidden within another image using deep neural network steganography. If the image is wrongfully stolen, the original author can reveal the copyright to claim his legal rights, and hence, digital media crimes can be prevented. Thus, that's all from me, and thank you for watching.